All right, in my previous video, I was going through this ANOVA analysis and we figured out that my F critical was less than my F value or my P value. These tell you the same thing. My P value was smaller than 0.05, which is my alpha. Both those tell me I should reject the null hypothesis and that one of these groups is different than the other. So I quickly wanted to run a post hoc analysis. Um, One of the best things you can do is to make a visualization. This is going to help you um, understand a little bit about what's going on in this ANOVA. So, and for comparing groups, I really like the box plot. So let's see if we can find it here. So we'll use the box plot here. And this really shows the mean of each of these groups, or in this case the median, and also the spread. So the center of each group and the spread of each group. So I have flashcards, I have memorization, and I have practice testing. And I can get a little bit more intuition for what's going on by looking at that chart. I'm going to go ahead and run my three t-test here. So I'm going to be a little lazy, and I'm going to use this data analysis tool pack. And here I'm using t-test. And I'm not going to run a check on variances, so I'm just going to assume unequal variance. And so I can go ahead and plug in my two ranges, so A and B, and I can give it some labels, and I'm just going to stick that one right here. So anytime I'm running multiple tests, my alpha tells me that I have this chance that I reject the null hypothesis when actually the difference was just due to random chance. And so there's always, if my alpha is 0.05, there's always a 5% chance that happens. If I run these tests over and over and over again, then I have a 5% chance, I have another 5% chance. The chances that I accidentally find a significant result, the more times I do that, it grows as I do these tests. It's just like if you have a 5% chance of winning the lottery, the more lottery tickets you buy, the better your chances are that one of those tickets will be a winning ticket. So what I do, I'm looking at a two-tailed test here to see if there's just any difference on each side. And I actually use a Bonferroni correction. And there, I either need to divide my p-value by 3 that I'm comparing to. And so if my alpha was equal to 0.05, then my p-value would be 0.05 divided by 3. That would be my significant p-value. And I like doing that way better because it makes more sense. Some people will multiply the p-value by 3, but then you have a chance of getting a p-value greater than 1, and it doesn't make any sense conceptually. Functionally, they're the same. Either way, it's pretty clear that there's no significant difference between, that we fail to reject the null, and that there's any difference between groups A and groups B. We'll do this again. Same test. Now, between groups A and group C, and I'm going to output that one right next to it. All right. Look at this. This one's actually pretty interesting because if I didn't use my Bonferroni correction, my p-value is less than my alpha, which tells me that there is a difference between groups A and group C. But if we use my correction here and I compare it to my new alpha, which is 0.016, this is not significant. And so this tells me I have insufficient evidence to say there's a difference between the students that studied with flashcards and the students that studied with practice testing. So even though these look shifted, there's enough overlap where we're saying that difference might just be due to random chance. Let's run our last test, which would be comparing group B to group C. And I'm going to stick that one here. All right, so this p-value is less than my alpha, but quite a bit. And so that tells me I do have sufficient statistical evidence to say that there is a difference between the students that studied via practice testing versus the students that studied via summarization. And so my post hoc analysis tells me that there is a difference between these two groups, but there's not a difference between any of the other groups, not a difference between A and C or B and A. So hopefully that's helpful on how to run that post hoc analysis. This could be really time consuming if you had a huge group if you have more than 3 samples, right? Like this grows exponentially as you have more groups. And so making this box plot ends up being really helpful because it helps illustrate which groups might have a significant difference than the others. So I like that visual method too. Thanks for watching. Hopefully that's helpful.